Well, thanks everyone for coming. This session is in its own right a bit of an experiment. This is something we've not tried before. What we're going to do today is try to put together a structure for a combined amateur radio contest and science data collection campaign. We've had a few events in the past that have been under the auspices of HamSci that have taken a form that's quite similar to a radio contest. But we're going to see if we can, instead of, coming at a science question from a contest perspective or a contest format with a science question, we're going to try to have both the ham side of the community and the science side of the community design this together. We're just doing kind of the broad outlines of things at the moment. This will take longer to figure out the specifics, but I'm going to show you a bit about the context of where I think this fits into things we might want to try in the future, and hopefully we'll come up with some good ideas. First, I'd like to thank and introduce our panelists, most of whom you've met at this point. Mike Black should be here among the panelists. Mike, can you say hello? Maybe?
There we go. Unmute.
Okay, cool. Hi.
Good morning.
All right. I think we've heard from everyone else at this point at one time or another, but Mike will be representing the frequency measuring test community. And so panelists, I know you guys are wondering how this is going to be structured. Mostly I just need folks around to help go through the discussion and manage the various ways that we'll be taking input as we get into the discussion portion. If we were in person, I would have us just all write this on whiteboards together. As is, we have a virtual whiteboard. There's also a Google Doc if you don't like to use that. And then there's the chat and the Q&A functions within Zoom. And you can get the links to the first things if you go to hamsci.org/co-design. So we're going to have both some synchronous discussion and some asynchronous discussion. All right, so briefly, where we're coming from on this particular notion of doing a co-design campaign. You may have seen this article that was published in the past month that covers some of the things that we're up to as an organization. And one of the points that I want to make about it is that the phrase citizen science doesn't actually appear in it anywhere. Instead, it uses crowdsourced science. And this is because within the scientific community, there's a more rigorous definition coming together of what citizen science is that has sort of a higher bar than what we typically think of. And this is one definition that comes from the National Academy of Sciences. There are a few different things out there, and there's a lot more discussion on what doesn't count as citizen science than what does. But the real core of it is that just crowdsourcing data collection is not enough. So the model that is often considered as being a basis for citizen science is this contributory model, where scientists design an experiment and then put out a call for volunteers. The volunteers collect the data or analyze the data. Then there's a collaborative model where there's a little bit more feedback from the volunteers on the experiment design, sometimes shows up in a subsequent iteration. What we're going for today is what's called a co-designed model or a co-created model, where the volunteer side is involved from the beginning of the experiment, including defining what the questions are and the approach to a science campaign. So a science campaign generally is usually convened to look at a specific phenomenon of interest. Geophysical phenomena have a lot of these. And when there's something interesting, you ask everyone who has instruments to point their instruments at the interesting thing. And then you look at all of the data together at the end of it. And this has a lot of similarity to an amateur radio contest, which has been bluntly defined as talking to as many people as possible, as quickly as possible, about as little as possible. For the scientists in the room who are not active contesters, the form that a radio contest typically takes is variable based on what the contest is meant to encourage. And not every ham radio event is a contest. The general umbrella for ham radio organized fun is radio sport. And the biggest example that usually comes up is field day. And if you look at the definition for field day and the documents and the forms that you fill out, it always says at the top, field day is not a contest. But it is contest shaped in many respects. Field day is an event that's held third weekend every June, I want to say. So I will, where for about a weekend, ham radio operators across North America set up an ad hoc communications network and then take it down again. And it's meant to fulfill two purposes. One is to encourage emergency communication. The other is for it to be ham radio's open house, to try to get as many new people as possible to try things out in the hobby. And because of this, there's a point structure for field day that is geared towards encouraging that particular set of things. So it's the only radio event that I'm aware of where you can get points for owning a fire extinguisher. Another example is School Club Roundup, where the purpose of it is to get children at schools and students at college clubs on the air. So the point structure there is structured so that schools versus individuals have different point counts, and it's worth a lot more points when you talk to a school. The result of this is that if you're a student at a school and you get on the air and you say, I am a school station, very quickly a whole lot of people will want to talk to you. And so the structure of the contest leads to the activity that it's meant to encourage. The contest that I'm interested in talking to you about adapting today is the frequency measuring test, which is an exercise in precision frequency estimation, which we'll get to a little bit later on. And the thing that I want you to be thinking of, if you're coming at this from the scientific side, is what we can do to use the tools of gamification that already exist in ham radio contests to leverage it towards science campaigns. So as I said, there have been some events in the past that have been contest-like. I think the one that I would call a true contest was the Solar Eclipse QSO party in 2017. Garrett's here who did the Golden Ears project, which required specialized capabilities among hams who were very good at Morse code. And then we've had the Festivals of Frequency Measurement, which was a shortwave listening kind of thing that required equipment but didn't really require skill. So we're trying to, if you make something more of a contest, it's very easy for it to give you a lousy data set. If you make something that's a really good data set, it's often quite boring to collect. And my hope is that we can reconcile this if we design the whole thing together. This is also something that if we meet with success this year, I'm hopeful will turn into sort of an annual cycle for us and keep the HamSci flywheel going, so to speak, where each year we could meet at the workshop, have a session where we design a contest, then in the course of the next year, run that contest, collect the data, write it up for publication, and then the next year hand it off to another team to do another one of these experiments. And from the perspective of the science community, this could then be a way to collect data for something of interest that's coming up in the following year. From the perspective of the amateur community, it's a series of radio events where you can participate and build your capabilities in different spheres of amateur radio each year. So we'll see if it works, and hopefully we'll have some sort of report out a year from now where we'll talk about whether this succeeded, if it's something that we're able to implement. So we'll be looking for volunteers in the course of today. This will be the last question on the list, is who's willing to be a team lead on the science side or on the amateur side. And these will be the responsibilities of both. And both will share in the communication and the management of the experiment, and also in the act of taking the results and analyzing them and bringing them to publication. So think about whether these are roles you'd like to take on. I'm sure we can accommodate multiple team leads. The next step, I think, based on what we would come up with today, would be to have a follow-up meeting and figure out how we want to structure it further. So the criteria for success in these co-designed campaigns would be that it would be autonomous, that the team leads would take it on, and it would be something where it's not reliant necessarily upon the HamSci leadership to be present at every stage of the process. It would require an actual, use of amateur radio rather than just the tools of amateur radio. So basically it has to be fun. And then it should be rigorous and scientifically defensible. It should have a solid basis in a science question that we can then take and convert to a publication and build a structure of inquiry within the literature. So in short, it needs to be organized, it needs to be fun, and it needs to be organized fun. Those are our goals here. So without further ado, here are the two things from the science world that we've been talking about combining for the experiment that we want to discuss today, which are vertical ionosons and the frequency measuring test. And Steve Serwin, I think, is still here today. Steve, are you in? Maybe? I don't know. Steve made
hit the unmute button. Yes, I'm here.
Oh, there you are. Steve made some mention at the end of his talk yesterday about doing some experiments with this, with having an ionoson that's in the Lowell did base set, and stationing his radio, relative to that, and then another radio on the other side. This is quite a similar setup to the way that the ARRL frequency measuring test works. And that is a radio sport contest that is, well, I suppose you'd call it a radio sport event because it's not accumulating contacts, but the FMT is just what it says on the tin. You've got a transmitting station, and this is my usual image for WWV, but instead of WWV, you have an operator who has a NIST traceable frequency standard who's transmitting a particular frequency. And then your receive stations are attempting to figure out what that frequency is. Now, the change in virtual ionospheric height and in refraction that cause this frequency to be affected at the receiving end by Doppler shift. For the FMT, that is it's a noise component. It's something that makes it harder for you to come up with a precise estimation of that frequency. If the ionosphere would just stop and hold still, then you would know what the frequency is at the transmitting side. But for the science case, this movement up and down is essentially our signal. So that's one of the things that we talked about is, scientifically taking this these two things and combining them into one. But we should talk about what science questions we could address specifically with it, how we would want to orient the stations relative to each other, and how to make that into an actual contest.
Christina, there's a couple of possibilities. One is to use the existing ionosons and just dispose amateur stations at the right geometry on either side of them. And so there you've got your ionoson data. But from what I heard yesterday, the Tangerine and other hardware is capable of being able to set this up anywhere, anytime. And since the Tangerine can transmit, it would need to get up to a few tens of watts because we are looking at narrow bandwidths. We don't need a lot of power. Our noise floor will be low. But boy, if we could put a waveform on there that would implement a time of flight, it would square the science payload. You'd not only get the Doppler shift, but you could correlate that with true times of flight, and it would really help a lot. Something like a chirp, an audio chirp, or as Phil suggested, a phase sequence of some kind, so that you can separate out the multiple simultaneous modes that happen, so they don't all fall on top of each other. We've done time of flight measurements using the time ticks from WWV, but the time difference between pops is only on the order of a millisecond. So if you're in the time domain, those things fall on top of each other and superimpose. If you could convert those to frequency or phase space, you could separate them and gather lots of data.
All right, well, give me a second because I want to get to that part of it. And these are good thoughts, and I want to get them into the documents we're putting together here. These were some of my notes. You've already covered some of them here, and we've discussed that a bit. The idea of combining the relative motion measurements, proxy measurements from Doppler shift with the ground truth from vertical ionosons. This is a map of ionosons that happen to be taking data during one of our previous experiments. That was the Festival of Frequency measurement, which there's a link to that paper on the co-design page. One thing that we noted might be interesting to measure would be the morning transition. So briefly, because we're a little constrained for time and this needs to be a discussion that we have, let's see, we've got an hour from this point. So I have kind of a 20 minutes knowing we'll probably go over assigned to each of these. And there's the chat and Q&A. And then also if you go to hamsci.org/co-design, there's a couple of links to different discussion formats. Panelists, I'm going to be relying on you guys to help monitor those. And then there's also an email sign up, and then we've got the chat and Q&A here in Zoom. So hopefully we'll be able to put together a good discussion on that basis. This is kind of the list of questions that I have to begin with of what our science questions should be, how we put it together as a radio sport event. And then again, finally, when we come to the end of the discussion, I'm gonna open up the floor and say who wants to actually work on running the thing, and we'll see about putting a team together to manage it. So here's research questions, and I don't know if we'll end up needing it, but I've got a timer up in the corner here. When the circle goes around twice, we know that it will have been 20 minutes. So here's the beginning of this, and then Nathaniel and Phil, I'd love to hear you guys lead this part of the discussion about what science questions we might be able to approach with the instruments that we have.
Thank you very much, Christina.
This is all happening in this session, like on our channel right now.
What's up, Phil?
I'm not quite. Hang on. I'm not. So this is all happening in discussion, not only in the document but here. I take it on this link. Is that
Yes.
Is that the idea? Okay.
That's right.
Yeah, so basically what I'm hoping is that we'll have a discussion here of these questions as we go through. And if you think of something relating to the science question portion when we're 10 minutes into the next part, you can go back to the links on the website and add something in there. But I think that primarily we'll be on Zoom for at least the first part of this.
I see.
Could you say one more time where the links are?
Yeah, in the lower right-hand corner of the slide, you see where it says hamsci.org/co-design. If you go to that site, you should be able to reach the links. And there's a Jamboard, which is a very popular platform for AGU things that is set up. And if you don't care for that, then there's also a Google Doc if you just want to put ideas in. So these would be things where once we've had some introductory discussion in the Zoom and we've convened our team leads, we'd come back to this and look at what people have suggested when we have a follow-up meeting to process what we've discussed in this one.
Right. And that's again hamsci.org/co-design, CODESIGN. It's now also in the chat, which is thank you, Liz, and other people. Okay, Nathaniel. So we need to start, I guess, with the science discussion a little bit.
That's right. And I think, one place we might be able to start is with, we could talk about Mike Rahonami's science questions this morning. And the other thing that I was thinking of too is, we just generally see a lot of variability in, or how do we capture this mid-latitude variability that we see in the ionosphere, in the mid-latitude ionosphere? How do we capture that in the context of a amateur radio contest? Here's what Mike put up this morning.
Oh, thank you.
You're welcome. So these are Mike's slides.
Right. So yeah, aside from the design of the experiment, we do have to sort of identify our goal to start with here.
Right.
Tim, are you expecting anybody?
Sorry, Lori, what was that? Oh, okay. Mic check.
So we have the topics that we've already started looking at. We've started looking at TIDs. We talk about that a lot.
Yep.
And with TIDs, we want to know when they happen, why they happen, what direction they're going. So that's something we know we can see at mid-latitudes. Also, we've seen from Dev's presentation yesterday, we know that, and from some of the, let's see, and from Mike's talk, we're interested in mid-latitude ionospheric irregularities. So those are another possible target. Again, why does it happen? Why does it happen is really the ultimate question, but leading up to that is, when does it happen? How do we predict it? Things like that.
And for the answer to the first question, so the first question here is, does the occurrence of ionospheric irregularities in the night side mid-latitude ionosphere impact propagation paths for HAMS? Why should they not impact? I think if there are, let us say, good irregularities, they must impact, right?
I mean,
it depends on what you mean by impact.
I mean, for some of this stuff, we have some, like microhanomy showed the AJ Ribeiro's paper where he was seeing these SAIS streams. There are a number of mid-latitude phenomena and signatures that are in the published literature that we just don't know how to look for them in an amateur radio sense.
Yes. So for some of these questions, I know the Ionoson was selected as being, routinely available data. We have to be a little bit careful that we're not trying to study a phenomenon that we can't verify is there through these other techniques that have already been published. For example, the stuff that Mike covered here is best seen in a lot of superdarn observations. So, in addition to the Ionosonde, you might need to make sure that you're doing these in fields of view where at least those mid-latitude radars could be operating.
Right.
On their normal cadence.
Right.
Could I jump in with a thought?
Please do.
Okay, so the first question is, or part of the first question is about where the occurrence of these irregularities happens. And I would imagine that a contest mode would be a way to get a broad geographic coverage of occurrence. And so that might be an interesting way that the citizen science approach gets you something that the traditional observations might be more limited because they are more tied to geographic locations. So that's one thought. My other thought relative to contesting is whether you would want the type of contest that is more spontaneous, we're waiting for an active day to do it type of thing, or something that is set up on a specific day where you don't necessarily know, you could just, it's the coverage on an average day kind of thing. So yeah, is that a good comment for this part of this discussion?
I think so. I think it leads into kind of what I was suggesting is, can we take some of the signatures that are already seen in the professional literature, and can we figure out how to observe them in the amateur community? And then can we extend that, like you said, to a contest situation where you have more broad coverage than just like one or two spots?
Right.
I think one of the challenges that I've noticed in this, so like I essentially organized the solar eclipse QSO party and did the analysis on that. The RBN Whisper PSK reporter data, there's a lot of it, but it's generally kind of low quality or not super detailed. So I could get big, very big picture sorts of ionospheric effects, and I could tease that out. But if I'm looking for, a very detailed or well calibrated effect, that's a very fine effect that's harder to see. And I think part of that is the sporadic nature of the amateur communication, where it's just one person talking as briefly as possible to another person, and you just log that information. It's a very coarse data point. As opposed to these cases where the scientific instruments are consistently looking at in a particular direction for an extended period of time using the same mode, and you're able to really observe how that path changes in time. It's a little bit more challenging here.
Yeah, Nathaniel, you want to motivate like the sort of regular calibrated observation.
Right.
With Aurorasaurus, one analog is that, people take photographs, and often they take photographs all over the sky wherever the aurora is. But if they take their photographs more in a time lapse of a given area of the sky, it's actually more valuable scientifically. So
yeah,
I
I think that's where where when Christina was listing her different contests that happen right now, the last one that she pointed to, the FMT, the frequency measurement test, is perhaps the one that is best suited toward this sort of adaptation, because it is a case where you're using carefully calibrated instruments, both on the transmit side and on the received side, and potentially for some more extended periods of time.
Yeah, I was wondering, Mike, if you could jump in and tell us a little bit about it.
Yeah, well, we last year we started implementing this FMT in FLDigi, and Dave W1HKJ is the primary author, and I worked with him on this. And I think he actually talked to somebody at Case Western too with it, getting in the most accurate measurement possible for the frequency. So like for the local calibration source here, I can measure down to 1 millihertz. And what I found, we normally do we do a monthly test right now. We do it at 6 p.m. Central Time. And what we found consistently is everybody's about 250 millihertz low. And we did a little daytime run, like on 20 meters, and everybody was spot on. I mean, within everybody was like 0.1 or 10 millihertz plus or minus. And I was thinking, actually, based on your discussion, that we could add another little feature to FLDigi that would actually be if Case Western, for example, provided a service side, we could send out a UDP packet that contains the calibrated frequency result and the station info. The server side could then determine if that station is calibrated correctly, because during daytime 20-meter WWV, everybody ought to be spot on. If you're not, then you're not calibrated correctly. It would be an ability for the science side to see that the amateur community is calibrated indeed correctly without having to go through a bunch of hoops to get there.
I think one of the tricks, though, that we've really learned in the past year, and a lot of this has come out of Steve Serwin's work, is that for the FMT community to really get things right, we really have to kind of get away from this idea that you just have you're measuring a single frequency at a single time, because things can split off into different modes, and really you need to capture the spectrum. And so we almost need to go back to the FMT frequency measurement mode and figure out a way to save the spectrum data or to represent that better, because part of that one reason you might be 250 millihertz off might be because the algorithm isn't able to handle that mode splitting that you see, especially during the dawn dusk transitions and during times. So I mean, even trying to rethink that is going to be I think something we need to do.
Yeah, the audio data would be harder because it's, of course, it's a much bigger load there.
Right.
Nathaniel, this is Phil. I'd like to step back, though, a little bit to the science thoughts about where geographically, okay, we would like to be able to measure these effects. I mean, it depends on where the transmitter is and where the receivers are. I assume we're still talking about transmissions from a central location. Is that what I'm talking about here?
Well, not necessarily. One thing that we talked about is since we already, if we have existing networks of ionosons, and our goal is to make it so that the control point, in this sense, the reflection point for the transmitter to the receiver, where each of those is a ham radio operator, is matched up with the point that that ionoson is investigating. And then use the ground truth of the ionoson as a point of comparison with what the operators are seeing. We could have sort of a constellation of people where, if I'm at a given point, then my control point might, for an operator on one side of one ionoson and then an operator on the other, I can coordinate people around, say, the continental United States.
Yeah, I understand that. So it would be good then to limit yourself to a number of defined ionosons just to control the scope of the problem. And then, to try to generate, I would think, N clusters of people participating on a circle around the control point, which would be vertically around the ionosons. So in some sense, this goes back to Nathaniel's comment about, it's more difficult to see the fine scale features in just a random set of collections from RBN or WhisperNet. You can see the general trends. So then I would say, and other people should chime in here, is that then you would want to select the ionosons so that, frankly, you had good coverage from, I would really suggest that you have good coverage from the normal operating super darn mid-latitude field of view. If you picked, say, 2 or 3 ionosons that were in that field of view and then collected your resources around those ionosons, that might be tractable enough that you wouldn't end up, when you analyzed it, with, well, there's extra stuff that we don't understand here, and I don't have enough contextual information to be able to then understand what's going on. So, that's a model that might give you that information for some of the particular things that Nathaniel has put on the screen that Mike Rahanami had mentioned. I'd like other comments from other people, though, on whether that's the tractable and useful model.
Bill, it seems like that's one possible model. Another goal of this contest could be designing a way so that those measurements do get calibrated, and other measurements that aren't near the ionosons can be used as well, or developing this contest as a calibration method that then gets used, helps you down the road. I'm not sure if that's anything somebody's thought of, but I think what you're suggesting is it sounds to me kind of like the way the scientists would design it.
Oh yeah, absolutely, and that's why I'm like,
ways. Yeah,
could be other ways, absolutely.
Another thing I just thought of is, in terms of, if we come back to these science questions, can we account for the formation of mid-latitude ionospheric irregularities? I think this is something we could potentially look at, because we might be able to see ionospheric irregularity signatures in some of the amateur radio communications. I'm not completely sure, so if other people, but okay, so one way I think you might be able to see it is if you take the FMT test, instead of just reporting the frequency, you report the amount of variability on that frequency. So if you just take a standard deviation measurement and report that as well, during periods of high variability, that might be corresponding with formation of mid-latitude ionospheric irregularities. Similarly, there might be some metric we can apply to other amateur radio modes that might show, that might indicate when some of these things are happening.
Nathaniel, could I barge in there, I guess.
Yes.
Related to the FMT, and in a matter, it's topical, but a matter of a shameless plug for Brian O'Donnell during the poster sessions. He's going to show some data collected by EPOP RRI of the FMT on April 24, 2020 that RRI collected. And the answer is yes, we do see not a nice steady key down signal with FMT. We see all sorts of variability in the polarization ratio, which tells us that something, unless the transmitter is acting all jittery, which I don't think is the issue, it's what we're receiving is a jittery signal, right? Due to a nice irregularities or something in the way along the medium. So that is
when you published your first RRI paper using the field day data, you were actually looking at the envelope of the DITs and the DAs in the CW, right? And you were able to derive information from that.
Right, and that was another comment I was going to make, and it was that, you know, FMT is really nice because it's a nice steady signal, and then you have your standard CW data that we collected during field day. What field day was that? 2015 field day, I think it was, where it was just a regular amateur out in the field transmitting on CW. And yeah, you're right. We were able to, you know, drill down to the DITs and DAs of individual hams, those K9 ESVs, DITs and DAs, and we were able to see this oscillation on top of their DITs and DAs and relate that to self mode fading, which is a pretty precise magneto-ionic effect. So, you know, the FMT is nice having that trustworthy standard, but you don't necessarily need that to do some nice plasma physics and some space physics with it. And we were also able to do other things like see cutoff and all sorts. So, you know, you can drive scientists, we can drive, I think, some very informative science information, some good knowledge just from, you know, the FMT standards, which are very highly precise and very well controlled, to the standard ham rig, which may not be, you know, run by a, you know, NIST standard oscillator and so on and so forth. We can get it from both.
Yeah. And you know what, that strikes me, like, you know, we now live in a time where computers are relatively inexpensive. We're talking about building the Tangerine SDR, which is going to have these phase locked GPS synchronized coherent receivers. You know, we're not, and will eventually also have transmitting capability. You could potentially run a standard CW contest or some other radio contest, which is quasi-random. But if we could do it in such a way that people submit wave files, or I basically, you know, raw IQ data files that we know are trustworthy in terms of their frequency content, that we could potentially develop a database and a way of analyzing, you know, even that large data set for small scale features.
Well, so one thing about doing it with this thing that we've talked about, you know, strategically placed FMT stations, both transmitters and receivers, is I think if we were to have multiple transmitters with a carefully selected set of, you know, frequencies and times, and we were to arrange them such that they were visible to multiple pieces of existing scientific infrastructure, then, you know, might we be able to do something interesting with these beacon signals is sort of the first question that I would have. And it sounds like there are, you know, some approaches for which this would be usable. Then, of course, the next question is, what do you want to ask of the community of hams?
Actually, thinking about this a little bit, for example, CW Skimmer is one of the most popular listens worldwide for all CW operations. Multiple slots and everything. Either that with a modification that could actually send out samples of those CW signals. Like I said, it's running, these things run 24 hours a day. There's hundreds of them out there. That could send these little small CW samples perhaps periodically, you know, like every minute, every 2 minutes, 5 minutes, whatever. You'd have a worldwide collection of exactly what Gareth was talking about, that are relatively small packets because they're only, 100 milliseconds wide or so for a key down. Using an existing piece of software, which CW Skimmer already does spot reporting.
Mm-hmm.
And I think it could be, since it's doing that, it's a fairly easy modification to say, send me out a small audio sample to some location.
It could be fun too, right? Like you could build in some fun aspects to the way that you, when you sent those out, or the pattern or something like that. I like that idea.
Yeah, generally for CW Skimmer, that thing runs in the background. You don't even know it's running. These guys run it more like a service for doing spotting. So that's part of the RBN network that Nathaniel was talking about earlier.
Mm-hmm.
It reports to the RBN network.
Yeah.
The problem with the FMT is it's a relatively small crowd. There's probably about 50 of us, maybe. Whereas if you do the CW Skimmer, you will get thousands of people broadcasting CW around the world. So it's a plethora of data potential there.
Well, there were 122 for the last ARRL FMT. Probably the practice FMTs, you guys would say you're getting about maybe 50 per session.
Oh, for the practice ones that we're doing monthly, it's more like about 8 to 10
Who
people.
are very, very enthusiastic.
Yes.
All right, and I know, a sizable chunk of that crowd is probably in this room.
So the other thing we can look at, Christina, and is this bullet point down here, can the HF observations be applied to test and develop models of ionospheric physics? We're starting to look at, you're starting to play with Farlap to do some modeling. Gareth is doing it, Steve's doing it, I'm trying to do it, Dev does it a little bit. That's kind of a link. We can look for some of the, we could take we could take some sort of predicted ionospheric phenomena that we see in the model, like subaurora ionospheric streams, and we could say, what should that look like in the model, use the ray tracing to compare that to the data, and then when we run the contest, we look at the contest for those particular signatures.
All right, well, let's talk about how the contest might be structured, because there's some interesting notions coming up in the chat. And Ward, if you want to jump in and let us know what you're thinking, there's some stuff here that probably is worth talking about.
Well, yeah, I've been looking into the FCC rules this morning while this is all going on. There have been a lot of efforts over the years to apply ham radio to various things, including data collection like buoys and various sounding techniques and data stations and things like that. And there has been, I'll put it this way, has been a reluctance on the part of leadership, both in the amateur community and at the FCC, to encourage this stuff, because they will say, look, this is not amateur radio. This is not two-way communications. This is the use of amateur radio by a non-amateur group. And there are other services and spectrum available for that kind of thing. So get out of here. Now, these days, the FCC is mostly concerned with selling spectrum and really kind of wishes we would all just go away. But you would still run into problems with trying to run these experiments directly on the ham bands. And below 30 megahertz, there are a completely different set of rules about beacons and automated stations as there are above 30 megahertz. So things like automated beacons and sounders and things like that, I think we could do that 50 megahertz and up. There are very few rules up there because that was the great wasteland for so long that they forgot to, make those rules apply. But below 30 megahertz, which is where all the interesting stuff is that we're talking about, it's very restricted as to what you can do. So I think the idea of let's focus on two-way communications with messages that incorporate useful scientific information is a good way to go, because then people can participate from a pure amateur two-way communications standpoint. And by the way, there's also signal to noise information and other, angle of arrival, or, who knows, kind of stuff that's embedded in the message. I think that's great. That's a terrific hybrid, and it serves, it fits the purpose of amateur radio. So you got to look at the basis and purpose, 97.1, and make sure that we're satisfying that.
I think I have an idea. Okay.
Go for it.
Okay. So what if we use like regular contest rules apply, but we'll have an everyone point their antenna north contest.
Sure.
Okay. So,
okay, that I could see is fitting right in. Yeah.
Oh,
and
that's interesting.
You could have these directional contests and you could have a series of them for different times a year.
Yes.
Or even during the contest. Yeah. So you have a directional, everyone points north, everyone points south, everyone points east, points west. And then you're able to test some of these things that Mike Krahanami was talking about, where like, can we see this off path propagation? And if you have a data set like that, then you could go back, look at it later. That would be fine. The FCC and the amateur radio community will be they'll be thrilled, because yeah, that's just two-way communication. And it's simple.
Nathaniel, for participation, the only thing you'd have to watch out for are those people who can't move their antennas.
That's true. And so they'd have to mark that in the log.
Yeah, or they'd have to say that my antenna, my little dipole, is pointed northwest and southeast. So for this contest, I'd be more or less able to hear things.
Right.
Yeah, and you can both have specific contests, like the solar eclipse QSO party, which is very focused on making measurements, or you can use the regular contest and create what I've been calling a contest within a contest, a CWAC, for a long time, where you create an overlay. Essentially, you participate and exchange information in the contest that's completely valid within the contest, but you are doing something special, like a certain power level, or you're pointing your antenna in a certain direction. It'd be great to have a website where Nathaniel types in, okay, everybody point your antennas at the geomagnetic North Pole, go. And so we're continuing to make contacts. We just all point our antennas in one direction. And then Nathaniel says, Simon says, point it west, and so then we all go over there and do that, or turn your powers up and down. It gets to be, a little goofy, I can imagine. But if you're in the big contest and you're exchanging information that's valid within the contest, they want the activity. So
Ward, I was going to say, we also had a comment from Chris KB3CS, and which is true, is for those people who, for all of the sodas, the and the POTAs, and the people who go out in the field and make measurements, a field campaign where you tell them, hey, if you don't have a fixed antenna at home, go out in the field and put up an inverted V or something fairly simple where you can orient it for that temporary period of time to the direction that we're calling. That's very powerful, because that engages the people who are doing all the mobile work.
Right. Yeah, the sodas, the POTAs, the IOTAs, the Walmart parking lot on the air groups. Yeah, and you go out and you give them a little category of their own. People love competing, but they want to compete against their peers, not against the giant stations of the world all the time. So if you have, hey, I'm a Omni class portable, on 6 meters. I went out and I put up my Squalo at, the prescribed, 3 meters or whatever. and you compete on that basis. Yeah, there's lots of stuff you can do, and you don't have to just, you know, run the whole darn contest. There's just look at contest calendar. There's so many contests out there. Figure out how to take advantage of that activity.
Yeah.
So to recap, we're talking about picking some all band, all mode contest that already exists and saying, if you want to additionally participate in this HamSci contest, fill out some form that you're doing so that we can then go back into the original contest logs and pull out your data and just point your antenna north.
Yeah.
Mm-hmm. Yeah.
It's different what we started with, but I like this idea.
This is very
I'm
simple.
a polar.
Yeah.
You have the polar category. I'm a polar. POLEER.
Yeah, you need a fun
Yeah,
name, fun name for the contest, and
No, I think
great. Yeah.
I think that's very powerful. It doesn't bend at all any of the rules that we were sort of worried about when we were getting a little fancier. And it also means that, as we've been talking about, there's a whole set of variations on that theme, right? You know, this year we're going to point toward the north and look for, you know, that kind of thing. Next time we're going to point east and look for magnetic field effects or something.
and what's great is
there a
already
time of the year when you've got more likelihood of
There's
getting
seasonal effects too.
reflections off the sides?
Yep. And Ward, your experience with the contest calendar, for example, you know that there's contest season and not contest season, and if there's a desire to spread out somehow the sort of
There
rather
are contests continuously.
okay
Every weekend.
The big ones occur. The big HF contests occur. We used to think, well, after the vernal equinox. I'm sorry, yeah, autumnal equinox. Between the equinoxes, equini is the traditional HF contest season, but they go on all the time now.
Okay.
I guess the question is, what would be the best time of the year, say, for example, to look for signals being reflected, you know, east-west signal paths being reflected from the north? What would be the best time of the year to look for that? Is it seasonal?
Nathaniel, I almost think that that's worth a literature search to see what super darn Mid-Latitude has been finding for the seasonality of those.
Yeah, that makes a lot of sense.
Yeah, we would want to try and set up such a contest like that at the right time of the year, so you'd actually get significant reflection off off some kind of a curtain in the north.
I would offer that's what we're researching.
Yeah, well, true, David, but you know, for people, there is a consideration about, you know, the contest, like turning. I mean, it's like Joe Jukevich talked about earlier. If you turn on your 6-meter radio and you get nothing, absolutely nothing back, you call and call and call and nothing happens. Not quite as exciting to the individual operator as at least trying to pick those events, those times to start with when you think you might have a better.
Yeah, that's true. But those of us who are into 6 meters are used to that.
Well, I was just using 6 meters as an example, but you know, the more HF oriented people may not necessarily be.
It would be good to know when it was more likely to get this started, but ultimately we want to know year round.
Well, so you could
You
put
will
out
find surprises.
Well, what's nice about that is, you know, you could have like a contest series. You know, one of the problems with the solar eclipse QSO party is that it's a one-off thing, right? It's just like, here it is. This is it. We knew what we were doing for that one day, but then what happens after that? But with a point north party or something that looks at seasonal effects, you know, we could potentially develop a series of contests that might build into this.
So can I make a comment here?
Yeah.
One of the things that I'm a big field day aficionado. Okay, so I do field day every year. One of the things that the QRP Club does is they take a specific contest or group of contests and they target them with, I want to say, a super set of rules. So you can operate the ARRL field day and you can operate in the normal ARRL field day. But if you follow these additional rules, like no more than 5 watts of power or whatever limitations you're going to put on it, then it becomes a separately scored contest for for us.
Mhm.
So you could target, and the beauty of it is you get lots of participants because you could target these contests that are scheduled way in advance, that are very popular, that recur over and over again. And you could say, okay, take NAQP and point your antennas north. And then that's your contest. And
Yeah.
you get all the participants and all the rules are already set up for you, except these few new ones that you add in that are our rules. And then you can submit your score to the NAQP, same as you always do.
And that's like what Ward was saying with the CWAC.
Yeah.
Yep.
Yeah.
Yeah, see,
That's a
could call
great
it
idea.
Contesting for science.
Yeah, there you go.
That's a great idea.
I think, Ward, you left the Science Weekly tests kind of flavor sort of thing, right? I mean, you
Yeah.
know, you have a series of these tests. They don't have to be weekly, but they could be on whatever cadence we can handle.
Yeah, and you know, you coordinate them by the internet, you know, and have a web page that this week's test, because there is a new sunspot group, or because there is a geo-effective CME, or something. We're going to, this is going to be 160 meters from 2 hours before your local dawn until 2 hours off after, or something like that. A bunch of us at one point were talking about doing a large scale continental coordinated 160 meter test to watch the dawn enhancement sweep across the continent. But it was too much work.
Okay.
But now we have a community that could do that. So
couldn't you treat this as a regular contest, as a bunch of signals of opportunity, and say, I don't even have a transmitter. I'm just going to tune in on the 160 contest and I'm going to listen, and they all have call signs, so you know where they all are, or their origins are. And especially if you're doing a CW contest, you could use CW Skimmer to copy the code, so you don't need to know the code to copy where they are, and then you look at the characteristics of their signals based upon their location. So,
and I think that would be a great way to get non-amateurs interested in amateur radio, because it's not licensed. There are not too many other activities where, you know, I want to participate. Well, here's a 450 question test that you have to take, and blah 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 blah, and the interest just goes.
Well, you know. but you know, Ward, but there's another nice, exciting idea in here, which is people have web SDRs, they have Kiwi SDRs, and so the minimal amount of investment is go use those tools and listen during this period. Tell us what you hear. The next step up is, here's some web pages that other people have put together on how to install an RTL dongle and a dipole if you'd like to do this yourself from your location. But look what Nathaniel just put up right there. Any of those, you can turn on the audio and just literally take your pencil and paper and say, at this time, I heard this.
And actually, that
there are
is
also
an
groups of
opportunity
shortwave
for,
listeners out there.
Yep, absolutely.
And some of those countries, they have to do it to get their license. So I think they would eat this up.
And yes, and Nathaniel is referring to the poster, right? That we're going to have in our session.
Here's a shameless plug for Shop's poster that I put together with the
I'll let you.
Ham Radio Club. We have a great collegiate shortwave listening contest.
Yeah, this one was a great little event. Well, you know, while we've got a few minutes here, though, I do want to point out, and just kind of to get the discussion started on this part of it. Okay, so say that we have this contest within a contest thing. What data set do we want to be analyzing when this is said and done? Are we looking at the code that you guys already have for looking at like RBN spots and what you already have for the solar eclipse QSO party? And what do we want to collect from people information wise, in addition to whatever we already get from the contest logs? And also, which contest would be good, I guess, is a follow-up question.
You can talk to WA7BNM, Bruce Horn. Bruce is the brains behind Contest Calendar. He handles all of the log uploading and stuff like that. And Bruce used to work for, well, he was like a major web architect for Kaiser Permanente. So he understands big data sets and of scientific value. So if there was a box that you could click on go to 3830 scores, 3830 scores.com. That's the after contest portal where you just report your claim score. That's not a web log upload. But if Bruce put a box in there, it said, would you like to fill out a form about, you know, your station, antennas, power, blah, 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 blah. And when you click that box, it opened up a set of information. You could collect a whole bunch of information from stations that are participating. And I want to point out the YODA group, Youngsters on the Air. I'm working with IARU to spin up information or interest here in Region 2, but Region 1's very active, and also Region 3 are starting to perk up. But getting non-licensed youth involved is a big effort across all 3 regions. And non-licensed participation in amateur events would be a great door opener for young operators. So we can leverage that interest too.
Hey, remember, Ward, you were getting SWL reports for your ham QSOs back in the 60s?
I get them all the time. I still get them in the Bureau and all that kind of thing. So yeah, there's interest. And with WebSDR out there, you don't even have to have a radio. You know, you don't have to have an antenna. You can just be a kid with a tablet. Yep. And that's our target audience right there.
Nathaniel, sorry, Christina. I was just going to say this. If you got to bring it back, I know, pretty soon. And the question though is that this is a little different than the solar eclipse QSO party in that there was an eclipse event. It started and it stopped, right?
Right.
This is much more of an ongoing series and frankly needs a working group, right? A sustained working group that would keep this momentum rolling, I would think.
I agree with that. Yeah, there will need to be a committee, or working group that needs to focus on this. But I think this is fantastic because, I mean, this in a lot of ways is, you know, what created HamSci to begin with, is doing this sort of QSO party. And this is the sort of thing that can really generate, you know, activity among the entire amateur community, really using amateur radio.
The big guns will love it because there'll be more stations to work.
Yeah, Liz, go ahead.
Yeah, so just to jump in on the entry mode non-licensed idea, I think it's also worth thinking about the things you're not thinking about. So young people might come with different skills of data visualization, for instance, and or analysis, you know, science points as well, that, you know, the science fair version of the contest, but it definitely wouldn't be a traditional ham contest, but especially in the context of citizen science and contributing useful things for HamSci, motivating some of the participation along the lines, especially of data visualization, following on from, you know, Tamitha's comment yesterday, I think would be good to think about as well.
Well, so this is also where we can do the same kind of thing that Field Day does, where it leverages stuff that is not technically related to ham radio, but sort of drives the whole thing forward. It's the fire extinguisher for points analogy. So maybe it could be something where it's like generate a visualization and submit it, and, you know, upload it at this link. And if you upload it at that link, then you automatically get some number of points in the HamSci leaderboard. And then you can, you know, you get to a certain number of points for HamSci in different contests, and you could have a long running point total that we could manage. And that kind of thing could be something that you could do to bring that point total up. So gamification could be something that would not just be short term for, like, you know, a specific contest we might be doing, like a solar eclipse QSO party or something that's driven by a geophysical event, but could also be something where you're accumulating points over time.
Yeah. Analysis of post-contest analysis is all the contests now, big ones, have public logs. So you can go harvest them and parse them and analyze them. You get guys like VE3 NEA, who wrote the CW Skimmer and a bunch of other stuff, or Rick, ZL2HAM and ViewProp is his thing. All these guys that are so good at data set manipulation and start having them post visualizations after the contest, like the RBN comparison charts and things like that. Tremendous interest.
As a adult leader who's led youth groups on field day for over 20 years, I can say that what you just said, Ward, is very interested. Our participants are very interested in that, especially the older youth who are approaching late high school, college age, where they've got the math skills, they got the visualization skills, and they want a little bit more out of it than just sitting in front of the mic and working people. Right. They want to, they love to see a visualization of, well, where were the stations that we worked and when, and like we were talking yesterday, make a movie out of this, so you can kind of visualize the 24-hour period of the contest some way, some novel way.
Mm-hmm. Yeah, one of the things that's really challenging existing contests right now, and this is a long discussion, so I'll just mention the idea. Problem is, contesting is based on information that you don't have and you need to get, and it's somehow obscured. So I need to use my skills to go out and make these contacts and get the information. Well, with all the online stuff now, everybody can receive and transmit from anywhere. So, and you know where they're receiving and transmitting. So all this previously hidden information is now public. So how do you have a competition in that environment? And I think we're ripe for some new thinking here. One of the things that we could start to do is use the grid map fields and say, I'm trying to get as many of these grid maps into my log as I can, and I get 1 hour credit for each one. So the number of grid hours that I can accumulate, you can see where this kind of thing goes. And so it ties into visualizations, it ties into operation, it ties into propagation mechanics. There's all sorts of things. So contesting 2.0 could really be an interesting evolution of the sport.
And this is one of the things that I was advocating at Dayton a few years ago, is how would you like to have contesting with no logging?
Right.
Because with this network of SDRs everywhere around the globe, every QSO is monitored. Mm-hmm. So you could technically, you could not log anything, and you could let the network of receivers log everything, and then it becomes just a statistical problem to solve.
There are at least 2 groups working on real-time QSO validation now, where you would not have a log. There is no other sport where you do not compete until after the contest is over. It's just the strangest thing. So they're working on submission of QSO data in real time, sort of like Logbook of the World, but runs in real time with a back end that shows scores and various other participation things.
Yes.
If I could jump in, one thing I want to point out, which I've talked to both Nathaniel and Christina about, is, you know, the HamSci in organizing these types of activities. You know, you're mashing together the amateur radio community and the professional, you know, in quotation marks, science community, right? And something I've experienced is that the time constant, I guess, for the amateur radio community and the science community are very different. In the academic community, the professional side, it takes a long time to take a data set from collection to actual end product publication. And I've been guilty of this before, where I've, you know, been in contact with the amateur radio community. They've sent me some stuff. I've been like, great, thank you. And then it kind of gets put on the back burner for a while, you know, there's other things that occupy my time, so on and so forth. So as professional scientists, we have to be very transparent about this, right? Because, and we have to kind of calibrate, I think, our expectations or our goals to reflect this, that, you know, there has, you know, if there's a contest, it may not be appearing in a publication within 3 months or 4 months or 5 months or 12 months, right? These things on our side of things, I should say, from my perspective, they take a long time to develop and to, because we unfortunately we're spread thin with, you know, our other academic duties. So And I think that's something everybody has to, at least the professional scientists, have to keep in mind.
And on a related note, I apologize to everybody in this meeting among the attendees who's still waiting for the results from last June. Because I know we've all had this experience of, you know, as Garrett said, you run the experiment and then it takes a lot of time. And, you know, I tell people as a rule of thumb, it's probably going to be maybe a year to analyze the data. So this is another thing that I'm wondering is, as we are building in on this, are there things that we can do to gamify some of that analysis? We've already talked about the putting in a visualization and having that be something that's worth points in this sort of HamSci contesting league. Are there other things where we can effectively take in analysis input from people or give people access to the data and build a stronger connection between the contesting and the process of publication?
Yeah, well, so you could offer points for analyses of certain data. I mean, I'm serious because our kids have a relatively low attention span, and when the contest is going, they're in there and they're making QSOs and they're going great. And then when it's over, oh yeah, well, we could analyze that. No, maybe we will. Oh wait, I got this game to play over here, and it's like it gets put on the back burner, and so then you end up not getting the results that you want. Well, okay, here's an opportunity for interested people who might not be interested in operating the contest, but they want to analyze what all you guys that operated the contest did, what your results were, who you talked to, that kind of thing. And like has been pointed out already, this data is already online for most contests.
So this is Phil. So there's got to be a parallel approach then, which is, yes, it's going to take science takes time. You have to do it right. But if there's even a crude indicator with the visualizations, I mean, the chat has been flying away here with visualizations. If there's some kind of real-time visualization we can put together that shows something about what we're doing, maybe it's not the final science conclusion, that people get that feedback that says, okay, I want to come back for that next. I fully realize that you're not, I mean, this is like the old tie up your radio for a year, please, and then maybe in a decade we'll tell you what you found. That's not going to work.
But so what you want is analysis like
can I jump in? Can I jump in real fast? Because I have a real, I'm sorry, I'm kind of chomping at the bit here.
Yeah.
There's an easy way to do that. There's a very easy way to do that. A lot of students, a lot of kids, a lot of people who are trying to, you know, go forward in their lives. They absolutely love the idea of being able to contribute to science, but they know they can only contribute things like little nuggets. They know they're not going to be able to contribute something grandiose, something in-depth, something along the lines of a JGR paper, let's say. You know, they're not going to be able to do that. But you take the NASA approach, right? NASA has all these little teeny tiny science nuggets that they do PR releases on. If you were to take that idea where, yes, you can use the visualizations, for example, you can either have the students do it or some of the amateurs do it. Anybody who wants to go in and do some of the analyses, they go in there and then they submit to, let's say, HamSci. Okay, you could even have, because HamSci has become a big, you know, a big symbol now, right? You could actually have a community publication page where people are able to actually either print their, you know, write their own little short science nuggets, or little white papers in a sense, or you could have people who aren't that good, let's say younger kids or even adults who hate writing, but they love analysis, submit certain, you know, little bits and pieces of their analysis. And if it makes sense, or if it's up to snuff and it's not completely garbage, this could be turned into a little science nugget that is published online. And you'd be amazed how many people would go crazy to see their name up in lights, so to speak, as a publication. Even if it's not totally peer reviewed, it's been, you know, kind of looked at least, not perused perhaps, but just at least scanned by somebody in the know. And so they feel that they get this validation, and they can point to their friends and go, look what I did, look what I did. And that kind of thing doesn't have to take a year. So the heavier in depth stuff can come out later, but some of this parallelization can actually help bring some of these young kids into the fold, even into the science fold, from the point of view of, hey, look, I got a publication, so to speak. Does that sound interesting?
Could you make it open-ended to a point where you could say, look, we got this data and we want to have unique visualizations. So you come up with some unique visualizations, write it, submit it, and then the HamSci bank of judges will say, well, look at these. We'll give these 10 and those a 9 and those, and you can grade them.
Have a visualization contest within a contest within a contest.
Yeah,
it's like a
Then you
poster
totally
session.
kind of
You
like
know,
writing
and-
a short story and submitting it. You
And
know,
the 8-year-old kid can draw a picture of what they did.
yeah.
You know, it doesn't necessarily need to be a scientific visualization. It doesn't necessarily need to be publication grade for everything we do. We
Right,
do
but
want to generate, obviously, things that are rigorous publications, but that can be something that is handled on the science side of things.
But then you might be surprised at what you get as results.
Oh,
you know,
yeah.
Yeah.
upper end.
If you'd have waved this red flag in front of my high school club, our grades would have taken about a 10% hit after every contest when we would jump on the computers and do this stuff. It was like candy.
Okay, well, we're at noon, and I know that there's some folks that want to, that Laura and Liz wanted to say something, but before we move on to the next break period, I do want to get folks signed up to help manage this. So I think, as Phil suggested, it'd be a really good idea for us to have a working group, to have a follow-up meeting. If you're interested in joining a mailing list to be a volunteer as part of this nascent contesting league, please join the mailing list. If you're interested in joining that committee as somebody to work on the strategy of this, I've put a link in the chat to the Google Doc, which is also linked on the co-design page. Just put your name and your call sign and your email, and I'll send a follow-up email with a little bit more information, and we'll see what other ideas we can put together. Thank you, Chris.
Sure to send that
Who
link in
writes, the
email.
trick for the mice is to have the cat bell itself.
There you go.
Yeah.
A self-belling cat. Is that
That
recursive?
is the goal, to be fair. So one other note, by the way, while we're talking about the gamification of it, I think one way to get quick feedback for the folks on the contesting side is to do this as a multiplier-based scoring system. So if you participate in field day and your station participates in field day and all of your data is reported and you have, say, pointed your antenna north for that contest and performed whatever additional constraints are applied to the HamSci contesting league, then your field day point total should be factored into your HamSci point total for that contest. And that way, you're just, however many contests you participated in, and we can talk more as a group about how we might make that system work well for new people as well as for inveterate contesters, so that somebody doesn't participate for this in 2 years and then like a new person can't ever catch up to them. But I think that having the existing contesting points, we can kind of leverage that as a way of making the gamification of it more complete and fair.
Contesting club I belong to has a annual point scoring system, and you get so many points for each contest. The bigger, more heavier duty contest it is, the more points you get. And then at the end of the year, it gets all reset and you start over again. And then they issue awards every year.
Yeah, I like that idea. That's kind of what I'm thinking of.
Yeah.
All right. Well, that brings us to our total. This was a very good session. I feel like we've got a good direction to follow. Thank you, everyone. And I think there was, Nathaniel, you said something about an announcement?
Yeah, so Laura and Liz would like to continue the conversation about inclusion to amateur radio. And so we're going to be talking about that in the next session over the lunch break. I'm not sure if we're going to do that in a breakout room yet or in the main room. We're still trying to figure that out. This is kind of, it's a little organic how we're trying to figure this out. So why don't I let Liz, why don't you talk about that for a minute?
Yeah, I don't know if everyone heard our talk yesterday, but definitely brought up some concerns from a newbie outsider's perspective about barriers to ham radio. And there was a lot of good discussion. And so we wanted to create a space for that. I don't know, it's certainly harder to do it in a breakout room, but a breakout room is also more private, so it does have benefit for this case. But
Why don't we, how about if we do it this way? Because I want the main room to be like kind of an open area. But why don't we start off in the open area? We'll open up the breakout rooms and we'll give you a chance to like get some people over to your breakout rooms.
yeah,
that sounds good.
that's fine. My thought was that, you know, if you want to stop by and chat a little bit about something, you're definitely not obligated to be there for the whole hour.
Yeah.
We would love to talk to specific people about, you know, I'd love to get some feedback on this consumer reports idea that I have of like all these ham activities. It'd be a lot easier to figure out what's actually a beginner activity or what are the requirements for different activities. That's one we didn't talk about in follow-up yesterday. And then also there are concerns about privacy and PII and how that intersects with personal space weather station. And, you know, future contests. And there may be ways that things about that I don't fully understand. And also, you know, on both sides, there's a lot of good discussion there.
All right. Nathaniel, can you open up some breakout rooms? Maybe we can have one for the diversity and inclusion conversation and maybe one for more contesting talk.